Section 6.7, solving radical equations and inequalities. We're going to start with the equations because that's the easy part here. Alright, you probably know what to do here. First thing I would want to do is add 1 to both sides. Once I've got that, I've got the square root of x minus 2 is equal to 6. So, the square root of what number minus 2 gives me 6? Well, you can probably guess that's going to be 38, but let's go ahead and work it out here. To get rid of the square root, I'm going to have to just square both sides, do the inverse operation. That's going to give me x minus 2 is equal to 36. Then I'm going to add 2 to both sides. X is going to equal 38. Quick check. Square root of, if I do 38 minus 2, that's going to be 36. Square root of 36 is 6 minus 1. That's going to give me 5. So that is correct. So we just isolated the square root function, then squared both sides to get rid of it. On the next example here, square root of x plus 5 is equal to 5 plus the square root of x. Well, I've got square roots on both sides. So I'm going to just pick one side first, get rid of that square root, and then I'll deal with the other side. So let's do this side first. I'm going to square both sides here. When I do this, this is square root of x plus 5 squared. That's going to become just x plus 5. This one, though, when I square it, I don't square just the two things on the inside. I have to FOIL it out. 5 plus the square root of x times 5 plus the square root of x. And to FOIL it out, 5 times 5 is 25. 5 times the square root of x is 5 square root of x. That's going to be the same thing, plus 5 more square root of x. Square root of x times the square root of x is just going to be square root of x squared, which is x. So x plus 5 is equal to 25 plus 5 square root of x. 5 square root of x is going to be 10 square root of x plus x. Alright. So, now what do we need to do? We need to get rid of this square root somehow. So let's get everything else over here. This problem works out nicely because when I subtract x from this side and x from this side, these cancel. I'm going to get 5 is equal to 25 plus 10 times the square root of x. So let me subtract 25 from both sides here. I'm going to get negative 20 is equal to 10 times the square root of x. And I want to get rid of this. I want to isolate the square root function here, so I'm going to divide both sides by 10. Now you probably see the problem here. The square root of what number gives me negative 2? Well, actually nothing. Nothing. I can't take the square root of any number and have it give me negative 2. But let's just go ahead and work it out for the sake of argument here. So if I square both sides, it looks like it's going to be 4. It looks like it's going to be 4. Let's plug it in and check. If I plug 4 into here, square root of 4 plus 5, well, that's going to be the square root of 9, which is just going to be 3. And if I do the other side, 5 plus the square root of x, it's going to give me 5 plus 2, which is 7. Does that work? No, it does not. So what can actually happen here is we may work the whole problem out and find there's actually no solution. That can happen. There's no solution to this. So this is what's called an extraneous solution. It's an extra solution, a solution that does not work. So when you get the answer, you still have to go back and check to see, does it actually work? Next one right over here. Going to have 3 times the square root of 5y minus 1. Not square root, the third root, minus 2 is equal to 0. So I'm going to rewrite this right here as 3 times the cubic root of 5y minus 1 minus 2 equals 0. So I'm going to add 2 to both sides here. You divide both sides by 3. Let those cancel out. And I've got the cubic root of 5y minus 1 is equal to 2/3. Now, how do I undo a cubic root? I cube both sides, of course. Cube both sides. So I'm going to get 5y minus 1 is equal to 2/3 cubed. Well, let's see here. I can just distribute that like that. 2 to the third over 3 to the third. 2 to the third is 8 over 27. So let me add 1 to both sides. 5y is equal to 8 over 27 plus 1. Now I'm going to rewrite this. Instead of plus 1, I'm going to make this 27 over 27. So that way I get 35 over 27. 35, not 25. So 5y is equal to 35 over 27. Then we'll divide both sides by 5. But instead of dividing both sides by 5, I'm a big kid. I know that I can just multiply both sides by 1/5. And those cancel out. Y is equal to, those cancel out beautifully. I'm going to get 7. 7 over 27. And if I were to plug this back in, this one does actually work out perfectly. Trust me on it. But you still always want to go back and check. Always go back and check to see if it actually works out or not. In the next one, we're going to be looking at how to deal with solving radical inequalities. Solving radical inequalities. All right. So right here, this number has to be greater than or equal to 5. Well, the first thing I got to do is figure out what numbers can I even plug in here? Because there's going to be some numbers that I can't plug in here that aren't allowed. So I know any number under a square root sign has to be, whatever's underneath here has to be greater than or equal to 0. Because I can't plug in negative numbers. So they have to be positive, or I can plug in 0. So that means 2x plus 2 has to be greater than or equal to 0. So that's what's underneath there. So if I subtract 2 from both sides, x is greater than or equal to -1. Quick check on a number line should work here. What if I checked x is equal to -2? If I plug in -2 here, that's going to give me -4 plus 2 is -2. Can I take the square root of -2? Not really. That's a joke. Haha, not really. Because it would give me an imaginary answer to give me the square root of -2, which is I times the square root of 2. So that one does not work there. Alright, so now that I know what numbers I'm even allowed to plug in here, let me go ahead and solve this normally now. So the square root of 2x plus 1, square root of 2x plus 2 plus 1 is going to be greater than or equal to 5. Well, that means the square root of 2x plus 2 is going to be greater than or equal to, sorry, my cat's trying to get in the way here. It's got to be greater than or equal to 4. And, excuse me, kitty. And so when I square both sides here, That's going to give me 2x plus 2 has to be greater than or equal to 16. This is easy to solve now. 2x has got to be greater than or equal to 14, and x has to be greater than or equal to 7. So it looks like x has got to be greater than or equal to 7. Let's check some numbers in between, though. So let me check a number in between here. Check what happens when x is equal to 0. If I were to have 0 in here, that's going to give me 2 times 0 plus 2. Well, that's just going to be the square root of 2. The square root of 2 is approximately... Is that bigger than 5? Excuse me, kitty. No, you don't get to... is that bigger than 5? Well, square root of 2 is approximately 1.414 plus 1. Is that bigger than 5? No, it is not. So that doesn't work. So let me check some numbers bigger. Let me check like the number 10. If I were to plug 10 in here, that's going to give me 20 plus 2. So the square root of 22 plus 1, is that bigger than or equal to 5? Well, this is going to be close to 5 itself. It's going to be like 4.7 or something. Plus 1, is that bigger than or equal to 5? You bet it is. So these numbers work over here. So my answer here is going to be x is greater than or equal to 7. This is always the way you want to do it. Find out what numbers under here are going to make it equal to 0. Solve it normally, and then check each interval. So once again, the steps. Find what numbers make what's under here greater than or equal to 0. Step 2 is solve it like an equation. So step 1, step 2, and step 3, check the numbers on a number line. And that's right down here where I checked -2. Oh, that didn't work. I checked 0, plugged in 0. That didn't work. Gave me a positive number there, but wasn't greater than 5. And check 10. Check something bigger than 7, and that one worked. That's the easiest way to do it. There is another way where you actually find out if it's greater than, it's going to be an OR problem, or if it's less than, it's going to be in between here. So if this were square root of 2x plus 2 plus 1 is less than or equal to 5, it would be everything from 1 to 7 here. -1 to 7. So be x is less than or equal to 7, but greater than or equal to -1. So if it's less than, it's going to be in between normally, and if it's greater than, it's going to be bigger than whatever number's in here. All right. So there are quiz trade cards with example problems of these on there. There are, you can always look in the book as well. You can also find other videos on YouTube if you need to. Just make sure you can do solving radical inequalities. Thanks for watching.